Greetings everyone. We will continue our discussion on information retrieval systems. In the previous session, we have looked about what is an inverted file and how to construct an inverted file by using your sorted arrays, and also I have introduced you to one modification regarding the construction of an inverted file for large data items. So in the previous session, we have looked about the conversion of inverted file and modifications to the basic method. I also told you about what is the single modification you can perform on the particular thing, and there is another modification which is fast inversion algorithm to perform inversion of your particular index faster. So we'll be looking at this particular fast inversion algorithm in this session. Okay. So as you know, in the previous session I introduced you to the two basic algorithms which are needed to modify the basic method of your inversion file construction by using your sorted array. The first particular thing is your inverted file for large data sets without sorting. The second one is your fast inversion algorithm. So the first one, the method I gave you in the last session, that is, we'll be taking the text, we'll be performing the parsing. While performing the parsing, while we'll be getting the keywords, we'll be inserting the keywords into one particular right-threaded binary tree. So this along with the right-threaded binary tree, we'll be constructing one linker list which contains the temporary postings file, and we'll be taking this right-threaded binary tree and the temporary postings file to create one dictionary and its related postings file, final postings file. This is particular actual inverted file. Okay, so with this we'll be getting what we'll be calling it as the inverted file without performing the sorting algorithm. Okay, since the sorting is very complex thing to perform, it will be taking lot of time. We are avoiding the sorting algorithm or sorting process by constructing the right-threaded binary tree and also your temporary postings file using your linker list. Okay, so we are avoiding the sorting process. So to improve upon this thing, actually we will not be considering the same process, we will be considering a different process to construct the particular indexing method. And I also compared the particular present method and the previous original method of your particular thing, and I told you whenever your particular size of your index is very small, when your text size is very small, your old method will work very much fine. But as the text size grows, okay, when you are going for larger memory bytes, okay, then we will be needing your new indexing method. Why? Because whenever you are having a larger text files, performing the sorting process will take more amount of your indexing time and also working storage, and you will be getting your index in some limited amount of time. So the new method will work very much fine for your larger text files, but it will take more processing time when you go for a smaller text files. So this is the comparison of your particular new method with old method. Okay. So the third method what you are going to learn as a part of this construction of your particular inverted files is your fast inversion algorithm. So this fast inversion algorithm, what is this fast inversion algorithm? So you are going to construct the same inverted file, your sorted array, by using your fast inversion algorithm. So the fast inversion algorithm is otherwise written like this, fast INV. Okay. This technique has two principles. Okay. What is the first principle is, it will take advantage of two principles. The first principle is the larger primary memory is available. Remember, whatever the two techniques you have seen in the previous sessions, those are somewhat older methods. Okay, so by the time this fast inversion algorithm was introduced, it was introduced in 1990. Okay, introduced in 1990s. So during the time, the particular computers or PCs which you are using, or the mainframes which we are using, had larger memories. Memories in the sense is the primary memory. So the primary memory size has been improved a lot during that times. So whatever the index you want to perform could be inserted directly into the memory. So the first advantage which the fast inversion algorithm took is the particular thing. So the larger primary memory is available on today's computers. As you know, as the generation progressed in your computers, there was larger primary memory. Okay. Next, the inherent order of your input data. Whatever the data that is going to be inserted into the particular IRS system, okay, it was already inherently sorted order. Okay, So whatever the order you are going to get, or whatever the data which you are going to get in the particular system is inherently in a sorted order. We are trying to make use of these two particular principles to develop your particular fast inversion algorithm. As you go in depth into the particular algorithm, you will get an idea what you are going to do. Okay, so what is the memories? So the first principle is important, since the personal computers with more than 1 MB of primary memory are common. As you know, in the present days 1 MB primary memory is very much common, and mainframes may have more than 100 MB of memory. So the first principle says that the primary memories of personal computers or other systems or mainframes have drastically improved over the years. Okay, what is the meaning of this particular thing? Even if the databases are of the order 1 gigabyte, okay, if they are in MBs, they can be easily moved into the main memory. Even if they are in 1 GB, they can be split into memory loads that can be rapidly processed and then combined, and the overall cost will be minimized. Okay, this thing, that is, whenever you are having larger memories, even if your database is 1 GB also. Okay, as I already told you in the previous sessions itself, this is one method where if you are having larger index file or larger text file, instead of sorting the particular thing at once, you can break it down into parts and sort the particular parts separately. Okay, I told you this method. This is not as it is, but you can understand that even if you are having a database of 1 GB, okay, they can be split into smaller parts or the smaller loads or memory loads. We can break them into smaller parts or smaller loads, and we can take the load into the main memory separately and combine the results. This particular thing can be applied whenever you are having better processor and larger main memories. Okay, whenever you are having better processors and larger main memories. If you are having the older memories where you are having 1 KB, 10 KB memories, at that time loading this much large amount of data will be very much complex. Okay, even if you are having 1 MB memory, or even if you are having 10 KB memory, and if your database is 10 MB, okay, loading the particular 10 MB into the main memory will be a complex thing for you. So to avoid all these issues, if you are having a larger main memories, it will be helpful for the particular indexing algorithm to perform faster. Either it can be loaded directly into the main memory, or if you are having a larger database like this, you can break down into parts and load it into the memory. Okay, that is the first principle which is applied in the fast inversion algorithm, having larger primer memories. So whenever you want to implement the fast inversion algorithm, your main memory should be larger. Based upon your implementation, if you are having larger databases, you need to be making it a larger primer memories. Okay, so that even if you break down the databases, your primary memory should be able to load large amounts of data. Okay, so the first principle you have to apply is larger primary memories. So the fast inversion algorithm follows these two principles. Okay, using primary memory in close to optimal fashion, that is, whatever may be the size of your primary memory, the fast inversion algorithm will use optimally. Even if you are having a 10 MB memory, it will use the particular 10 MB memory in an optimal fashion. Okay, remember the memory in the sense primary memory. Okay, database will be present in the secondary memory, but whatever the memory, if you are considering is the primary memory. Even if your primary memory is the 10 MB memory, so the particular faster inversion algorithm will use it optimally. Okay, so even if your database is 1 GB, it will break it down into parts, into 10 MB parts, and it will move all the 10 MB parts in an optimal fashion. And processing the data in 3 different phases. Okay, you are going to particularly perform this particular fast and inversion algorithm in 3 phases. What are the 3 phases? So the input first, before going to the phases, the first thing is the input to the fast inversion algorithm is a document vector file containing the concept vectors for each document in the collection to be indexed. So you need not be concerned about too much of terminology here. Okay, I think you remember the first step in the previous methods where you will be creating a document and where you will be creating your terms. I think if you remember, we'll be having terms and record numbers. Okay, the terms and record numbers. In the similar manner, we'll be having something called as concept vectors. So whatever this table, we'll be calling it as a vector file. Okay, we'll be dealing them in vectors. So that is why we'll be calling this similar file, whatever the initial file you have seen in the previous methods, that thing will be calling it as a vector file here, containing concept vectors. Okay, concept vectors, the concept word is same like your term here. The concept word is same like your term here. We'll be calling it as concept word. For the concept vectors for each document in the collections to be indexed. The collection means all the set of terms all the set of terms which are to be indexed in a particular document. Okay, we will be having a predefined collection of words or collection of terms which need to be indexed. So what we are trying to define is, we will be having a collection. Okay, this collection will be predefined. We will be having a terms which are needed to be indexed. From this thing, we will be creating concept vectors. Okay, these concept vectors are nothing but term vectors. Okay, and which document is containing which term will be defining in the similar manner. Okay, just this is a difference in a terminology fashion, but otherwise it will be a similar thing like this, where you will be creating an initial file in the previous two methods. Okay, in the similar manner we will be creating something called as a document vector file. Okay, which is containing concept vectors. Concept vectors is like your terms like this, terms and document numbers. For each document, that is, in the particular document, how many concepts are present or how many terms are present, okay, from the collection of your particular terms. So we'll be having a concept vector file containing whatever the concepts that are present in that particular document and what are the particular terms. So we'll be looking at an example for this particular document vector file. So if you see a document vector file, this is how a document vector file is present. So in the previous thing, if you have seen, as I told you in the previous methods, we will be having our term and record number or document number. Okay, so as you keep passing your particular terms, we will be getting the terms T1, T2, T3. Okay, you will be getting the parsing terms one by one, and we have to note down the document in which the particular term is present. This is how your basic term will work in the previous methods. This is what we will be calling it as the initial file in the previous two methods. A similar initial file we will be calling it as the vector file here, or concept vector file. We will be calling it as concept vector file. So the concept vector file will contain, okay, so in the first document, that is document 1, what are the concepts which are present? That is, this is concept 3, concept 5, concept 12, concept 14. So these 3 or 4 concepts are present in document 1. So from where these concepts will come? So these concepts will come from a collection. Okay, so this particular concepts will come from a collection of terms or concepts which are to be indexed. We will be having a predefined collection here. So every information retrieval system which you are trying to design, we will first design the collection. Okay, in that collection we will be mentioning what are the terms or concepts which are to be indexed in this particular information retrieval system. Okay, we will be having a predefined collection of terms or concepts. Those concepts will be mentioned here. Okay, we will be having all the list of concepts which are to be indexed. So in your document 1 will be having third concept, 5 concept, 12th concept, 4th concept. Okay, in the similar manner, we will be having the document 2 and its set of concepts, document 3 and its set of concepts. Okay, your complete information retrieval system, your complete set of documents will be stored in this particular order. As you could see, your concept vector file will be containing your document number and its concepts. And these are, as you see, they are present in a sorted order directly according to the document number. Okay, if you have remembered, you will be having a similar file in the previous thing like this. We will be getting the documents one by one, that is T5, T1 in the document 1, T5 in the document 1, T2 in the document 2, T3 in the document 2. In the similar manner, we will be having an initial file in the previous two methods. In the similar manner, we will be having something called as the concept vector file, where you will be storing the concepts which are derived from your collections based upon the documents. So first we will be having this particular concept vector file. Remember, this concept vector file is derived directly, which will act as input to your particular past inversion algorithm. So this will be created by the system initially. So while creating your particular index, before creating your index, we will first create your concept vector file. This concept vector file will act as input to your past inversion algorithm. So as you could see, the document numbers appear on the left hand side column, and the concept number of the words in each document appear in the right hand side column. So if you have seen in the previous thing, the document number will appear in the left hand side column and the concept number will appear on the right hand side column. And this is similar to your initial word list, except that the words are represented by concept numbers, one concept number for each unique word in the collection. As I told you, this will be similar like your initial word list in the previous two methods, where your words are represented by concept numbers and each concept number is a unique number is given for a unique word in your collection. Okay. So, however, the document vector file is in a sorted order so that the concept numbers are sorted within the document numbers and the document numbers are sorted within the collection. As you could see in the previous example, the particular things, they will be sorted in a document order. In a particular thing, in the complete collection, of your particular concept vector file, this will be present as a document sorted list. As you could see, we will be having first document, second document, third document. Inside the document also we will be having the particular concepts in a sorted list. The concept, that is 3, 5, 12, 14, 1, 3, 4, 11, 12, like this. So we will be having the documents in the sorted order. Inside the documents we will be having the concepts in the sorted order. Okay, by default, while creating this inverted file itself, we will be performing all these things. So as I told you, however, the document vector file is in sorted order so that concept numbers are sorted within the document. Okay, concept numbers are sorted within the documents and the document numbers are sorted inside the complete collection. So the algorithm involves three phases. The first phase will be calling it as the preparation phase. The second phase will be calling it as the splitting the document vector file. The third phase will be calling it as the inversion phase. Okay, we will be looking at these three phases one by one, that is preparation phase, splitting phase, inversion phase. What is the preparation? The outline of the particular algorithm is in this manner. We will be having the input file, that is the document vector file. Okay, which will be performing the preparation process. In the preparation process, we will be creating two files, something called as the concept files, or your concept files will be calling, as you have seen in the previous methods, we will be creating the concept files. So we will be having the concept files and the load table here. We will be using the particular load table to perform the splitting of your particular thing. This is the second step. Okay. And using the concept file, we will be performing the inversion process. Okay, so we will be having the three steps. The first step we will be calling it as the preparation. The second step we will be calling it as the splitting process. The third step we will be calling it as the inversion process. Once after performing the inversion, we will be getting the complete inverted file. So we will be looking at these steps. The first step, preparation process. In the first pass, the entire document vector file can be read and 2 files are produced. As I told you, in the preparation process, we will take the document vector file, that is will be the input of your inversion algorithm. Okay, we will be taking the document vector file and we will be creating 2 new files from that particular document vector file. Those files will be calling it as the contents posting file. Okay, the concept postings file, I think you remember the postings file in the previous methods. In the similar manner, we will be having the concept postings file and the second one a load table. So we will be creating these 2 tables or formats. The first thing is concepts file, the second one is the load table. So this is the first preparation of the 2 things. If you see properly, this is the input vector file or your document vector file. In the document vector file, we will be having the document numbers 1, 2, 3, 4, 5. Okay. In the first document, we will be having the 4 concepts. In the second document, we will be having the next 5 concepts. The third document, we will be having the next 5 concepts. Fourth document, we will be having the next 5. And fifth document, we will be having the next 4 concepts. These are the concepts which you are having. This will be calling it as your document vector file. From the document vector file, you are going to create 2 files. One will be calling it as the concept postings file. Another one is the load table. So what is the concept postings file? If you take here, we will be taking the concept numbers, that is 1, 2, 3, 4. Okay. So the concept number 1 is present in your particular second document. Okay. The concept number 1 is present in second document and it is present as first element. That is why the offset is 0. Okay, that is why the offset is 0. In the similar manner, the second concept, where is second concept? The second concept is also present here in the third document. Okay, in the third document, second offset number. So we'll be taking this particular thing and we'll be creating one load. So we'll be creating 3 different loads. For each and every concept, we will be taking concepts from here and we will be making where is the number of documents in which the particular thing is present. For example, 1 is present in 2 documents. It is present in second document and fourth document. And if you take 2 is present in offset 2. Offset 2 means it will be present. This is first document, this is second document. Offset means it is present as the third document. So it is present in offset 2 and it is present as one time. And if you take the third concept, concept 3 is present in the fifth document. So concept 3 is present with fifth document, that is why we will be keeping it as offset 3. So sorry, that is present as 3 times. And concept 4 is present in 2 documents. So we are going to keep this particular concepts and its offset where it is present and the particular number of times it is present, and we are going to mark it as the load number. So the load number means what is the basically thing you have to do is you have to take the set of concepts and divide it into a splitting like thing. Okay, before actual splitting you are going to create the loads based upon your main memory. Okay, whatever may be the size of your particular concepts file, you have to take the concepts file and break it down in such a manner that you should be able to fit the particular thing in one load. That load should be able to be moved into your particular main memory. As I told you, the main principle of your fast inversion algorithm is you have to be able to use your main memory optimally for indexing. Okay, so in order to move your main or use your main memory optimally for indexing, okay, you should be able to break down your particular text file or your concepts file in such a manner that you should be able to break down the particular thing into memory loads. Those memory loads should be able to be loaded into your particular primary memory. Okay, so that is why you are going to have these 2 things. Okay, the first one, you are going to have loads. Inside the loads, Okay, we'll be having the number of tuples which are present in your concepts file. That is, load 1 is having 6 tuples or 8 tuples, load 2 is having 6 tuples, load 3 is having 9 tuples, like this. Okay, what will be the starting concept, what will be the ending concept, the number of concepts, like this. Okay, you should be able to comprehend this particular thing, and you should be able to understand that we are going to create your particular concept postings file and load table in such a manner that you should be able to load on particular load into the main memory. Okay, in the next session we will be looking about how to create these loads, how you are going to get this complete file properly, that is how you are going to get this particular file from this one. Okay, with proper example we will be looking at how you are going to get the postings file and the load file, how this particular postings file and load file will be used for your splitting process, and from the splitting process how you are going to perform the inversion process. Okay, you are going to perform all these three steps, that is your preparation, your splitting and your inversion process. We will be looking at the remaining 2 steps in the next session. We will close this session. Thank you.